Yeah, I hope you've been having a good time so far. It's been a great turnout. Thanks for your attention. First of all, my name is Can. It's pronounced Can. I've been with Multi-Linux Manager team for 9 years now, and I'm based in Berlin. Today I'm going to talk about API-driven automation with the upcoming role-based access control feature in Multi-Linux Manager. I'm going to deep dive a little bit into technicality. I hope I won't bore anyone. I'm going to be showing you some coding examples and such. So I have a very packed agenda, so I will keep the boring stuff to a minimum to go over them very quickly, and I want to focus more on the use cases and examples. I have some cool stuff to show to you. So yeah, let's get it over with. First of all, why do we care about about automation, secure automation? The answers are usually obvious. First of all, I could say none of our customers nowadays have a very homogeneous systems. Like, they're all complex and diverse Linux environments, including different distributions, different versions of those distributions and such. And yeah, with different flavors, vendors, it's a really complex thing to take care of everything manually with clicks and stuff like that. And the challenge of managing systems at scale is like configuration management or systems management is a really repetitive task. And even if you know by heart what you need to do, every time you click through some pages to do something, there is a chance of inconsistencies. Which brings me to the third point, like errors, inconsistencies, and vulnerabilities of manual processes. Like, you cannot be 100% sure that you're following the same exact steps every time. And of course, also for efficiency and agility. So bigger the environment goes, you need to take steps towards automation for efficiency. And also, automation is a powerful concept. So with automation, you have to make sure that you're securing your processes and the agents you're using for those automations. So first concept I'm talking about is the role-based access control for securing access. So in general terms, role-based access control follows the principle of least privilege. That means when you define users to do your steps for automation, you want those users to be able to do those tasks and exactly those tasks, nothing more, nothing less. Second of all, granular control is that I want to be able to have a say on what those agents are able to do in the most fine-grained way as possible. And the third point is the separation of duties. I might have different users and different users of different nature. I might have human users, I might have API automation users, CI users, whatever. So they should have all separate duties, and they should not affect each other in a way. And lastly, maybe the most importantly, role-based access control provides us with auditability. And yeah, with RBAC, every step of the way, the actions are logged in a structured format that you can audit, browse, or report. So how do we tackle this in Multi-Linux Manager? So if you're familiar with the product, it's the first upstream version of our product is more than 20 years old now. And from that day, since we inherited that, with every release, we're introducing more features, we're making it more and more robust. And that makes it a very huge code base, a very big beast of a program. So implementing such a feature, which has to touch every existing feature in the whole product, is a challenging task. And that leads us to make some important design decisions. And yeah, quickly talking about those. For example, we're going to manage access or filter access in a single centralized place by the endpoints. Here, by endpoints, I mean every web endpoint that Multi-Linux Manager has or responds to. This could be an endpoint that renders a web page. This could be an internal API that we have using for asynchronous communication. or this can be a public API endpoint. If every web URL is an endpoint. So we are restricting or controlling access by those endpoints. We are going to have, of course, granular control of both the web UI, any page, any view, any list, any form, plus all the API methods that exist. Access is going to be organized by a concept we call namespaces. So I'm going to talk a little bit more about namespaces in a couple of slides, but let's go over this list for now. So users are going to be assigned to roles, of course, as the name suggests. So how those roles will look like is that, again, if you're familiar with the product, we have a handful of predefined roles that already exist since the beginning. Those are just a handful of static roles, and they control access to major features of the product. Like, for example, system administration. Maybe that's everything you're interested in for some people in MLM, but it's a huge part, and you cannot more granularly control it so far. Similar with the other rules. So that's it. That's what you get in terms of access control. There's no elasticity in that. So in the new implementation, role-based access control implementation, we are going to transfer all the existing rules into the new system so that our users can keep using MLM without noticing any change in implementation of role-based access control until you are ready to get into it. So in the RBAC feature, it's going to work as like, of course, we're going to have all the existing rules available, and you're going to be able to define new additional roles, either starting from those existing ones, like inheriting the access rules from those and adding and removing additional access is per your needs, or you can, of course, start from scratch and pick every feature that your user is going to be able to access one by one. So going back to the concept of namespaces. So namespaces are basically, they are bits of functionality in MLM. So every bit of functionality is defined with a namespace. And they are going to be organized in a tree-like structure where the parent nodes are going to be, again, the most widest pieces of features. Like, for example, in the example you can see the top level, there's systems. It is everything related to system management. And with each level of nodes, that the access control is going to be more granular. So here in the example, you can see in the second level is its details, which controls access for managing details of a system. And then when you go to the third level, there's this 3 different namespaces: overview, reboot, and remote commands. So connecting those levels, for example, systems.details.overview is going to make up in one namespace. Systems.details.reboot is another namespace. So you can play around with all these namespaces and make it a collection and make it a user group. So you can control access with those groups. There is also an additional level of granularity by modes, view and modify. Here in the example, you can see that it's only available for the systems.details.overview. So of course, some namespaces don't make sense for both. Like, for example, systems.details.reboot is obviously a modify operation, so there's only modify for that. But in most cases, there will be both view and modify options. So here it means if you have view access to systems.details.overview, you'll be able to view the system's details, but not be able to make any changes on that. But if you have the modify mode on, you will be able to change any of the system properties as well. Here's another more complete list of the namespaces to give you an idea how it looked like in the end. This will be able to be also browsable in the web UI, so you can pick and choose with some well-written descriptions. Looking at a couple of more examples here, right on top we have cm.build. By the way, cm is here the top level of that namespace tree, and cm stands for content management. It's a legacy name for image management we have in MLM. And image management, by image management, I mean container images or OS images. So on top, cm.build lets you access to build container QE images, OS images. And for example, there's cm.profile.details, let's say, right in the middle. We have view mode, we have a modify mode, and the view mode will let you view the details of an image, which system it's been built on, where these details are, where the Docker file comes from, also maybe CV audit results, etc. But the modify access will provide access to create image profiles and edit those details. Well, this is how we envision role-based access control going to look like in MLM. Now I want to switch over to the API part of it. And I know like API has been there all since the beginning, but there's never enough information we were able to share so people can use it to its full potential. So I'm going to want to emphasize on the API part in this presentation. I have a couple of cool features that I think they're cool to show to you. But before that, I want to talk about the API in MLM a little bit also. So in general, first of all, why do we care about the API? Why do we need the API? So first, of course, it's programmatic access. Like we're all tech people here, and personally, I prefer to interact with everything, with the world, in a programmatic way. That's deterministic, and that's how my brain works. So API provides us with just that, instead of like browsing through pages, clicking here and there, and this is the most efficient way that we can interact with any system, I think. And second of all, integration. Of course, so no system is working in isolation anymore. So everything is a piece of something bigger. And what we're just doing as tech people is we are just connecting the piece of a puzzle, and we are trying to figure out the interfaces between those pieces. So that is integration that comes with API. And consistency, of course, like when you're doing a repetitive task, and like I said, even if you know your stuff very well, there's always a chance to diverge from what you want to do. But with the well-written API code, you can make sure that it's going to run in the same way all over and over again. And finally, so that's one of the most exciting points for me nowadays is the AI readiness for intelligent automation. So however smart your AI agent is, it is still a big curve for AI to be able to read your UIs, web UIs, and do operations. So of course it's going to be possible, but there's still a huge step towards that. But with a well-designed, powerful API, complete API, it lowers the barrier a lot for your AI agents to be able to interact with your system. So APIs are intended to be read by machines anyway. So what do we have in MLM in terms of APIs? We have two APIs in MLM. First one being XML-RPC, which was there since the beginning. And the second one is more recently introduced, is JSON over HTTP API. As the name suggests, the second one works with HTTP requests. They are both fully functional, full-featured APIs, and they are basically identical to each other. And the reason is the business logic in the backend is basically the same. So these two APIs are just two facets of the same business logic. So you can mix and match depending on how you want to interact with the API. For example, the first one, XML-RPC, is well-established protocol for remote procedure calls, which helps you write more structured, more complete code. But in my opinion, for the second one is more lightweight approach. Like it's just a simple request to a HTTP endpoint, and then there you go. So it really depends on how you want to interact with the API. So from this point, I'm going to start showing you some code snippets. I hope they won't be too confusing, but I'm going to keep it simple. So first off, I'm going to show you how to interact with these two APIs with the simplest possible code parts. Let's start with XML-RPC. Here you can see a Python code. I'm just going to give you a quick second to glance through the code, and then we'll talk about it. So here the key points are, first up, I'm using the xmlrpc.client. It's the standard client library for xmlrpc in Python, but I'm pretty sure in almost every language you can find a well-designed client to interact with it. So one of the beauties of this client is that it reads the API signature and it creates you the dictionaries to work with it. So like you can work with those API endpoints like they are parts of the dictionary objects here. So I highlighted three different calls here, which are the actual API calls we're doing. This is the bare bones API interaction in Multi-Linux Manager. So first up, we're calling the auth.login endpoint, which is, obviously login. And this returns me a session key. And this session key is going to be the first argument that I'm going to use from now on for every method call I'm making. As you can see also in this second call to user.listUsers, the only argument needed is the key by default. And then I'm just printing the list of users, and then I'm logging out. In the next page, now I'm going to show you the same example with JSON over HTTP. Again, 1 second for a glance. So probably obvious, this is a command line interface. It's not a language, well, bash, let's say. And I'm using curl to especially show the different ways of interacting with two APIs. So we are doing the same calls, but our interaction, our input and output is very different here. So it really totally depends on how you want to interact with it. Here, the operations are exactly the same with the previous one. First, I'm logging in and sending a JSON payload to the login function with my credentials. And then I'm calling the user/list_users method, and I get a JSON response for the list of users, which is only one here. And finally, I'm logging out again. So this is how we interface with the API. And now I'm going to show you a couple of more exciting use cases that I think there are good ideas to utilize the API. So we're going to start from simpler to more complex ones. But yeah, please just you can feel free to ask any questions for any line of code there. And yeah, I want to go as slow as possible. So first one here is how to create a new role, as in role-based access control. So again, let's have a look for a second at the code. So here, the steps are pretty simple. The step labeled as 1 is the same kind of login thing that we already seen. And in the second one, I'm calling the API endpoint access.createGroup to create a new user group. And the arguments here is, first one is the session key, which will always be there, so we can ignore it from now on. After that, there comes the name of the new group that I called patch administrator. And in the third argument, I have a list of existing system groups that I want to inherit the roles from. And there are system administrators and image administrators. So I want the patch administrator to have everything that those two has. And in the next step, I'm going to add a little bit more, a few more permissions to that. So as you can see in the third step, I'm calling access.grantAccess. And the arguments here is the first one is a list of namespaces that I want to grant access for. And if you notice here, there's a wildcard, software.asterisk. And that'll mean everything under software. So everything related to software management, I want to grant access to. And in the next argument, I provide view, as in view mode. So that will basically mean I want this user to be able to access every view operation regarding software management. And the last argument is the patch administrator, which is just created. And the fourth step, I'm going to add even more permissions. But this time, these new namespaces are going to be view and modify. And if you take a look carefully to the namespace here, it's software.channels.asterisk. Actually, the third step would cover software.channels as well. But the third step is just for view. So for software.channels subtree, I want both view and modify access. And with that, when I'm finished managing the rules for access, then I'm done with the new group. And then at step 5, I just log out. Here quickly another example to create a role. This time we're going to start from scratch, not inheriting anything. And actually this time the user I'm going to create is the user I'm going to use in the next examples I'm going to show to you. So here the namespaces are the things that we're going to actually use in the next steps. So if you notice also here, the namespace all start with API. So API is a parent level node in this namespace tree, and that controls access to every API endpoint. And this is probably the most fine-grained you can go, because with this you can manage access to every individual API endpoint. So here in the first step, I have a bunch of view-only namespaces that I will send to the API later. And at the second step, there's more namespaces which I want both view and modify access for. And when we go over to the third step, I create a new group that's called CI reporter with an empty list at the end saying that I don't want to inherit from anywhere. At the first step, I call, there are two calls to access.grantAccess with each of those list of namespaces that I created before. First one being the view-only namespaces with the only view argument there, providing us view access, and the second one with both view and modify modes. And then finally, with this group, I'm creating a user here called CI-reporter with a password, an email, and of course the role this user has. So with this user, now let's do some operations. So first example I want to show you is how to build a container image automatically when you push a commit to a Docker file online. So first of all, before you even look at the code, the trigger part is not here. So this doesn't trigger automatically. So how you would do it is, most preferably, you would probably have something like a webhook that initiates this whenever you make a commit. Of course, that's the most common way, I guess. But imagine that somehow your Git environment triggers this with a webhook, and this script executes. So starting from there, first up is, of course, like always, we log in, this time as the CI-reporter user. And the first step I want to do is I want to get a list of build hosts that are registered to Multi-Linux managers. Build hosts, by build hosts, I'm talking about container build hosts. Those are systems registered in Multi-Linux Manager that we know, or MLM knows, that are able to build containers. So I do it by a call to system.list systems with entitlement. And the entitlement I'm looking for is container_build_host. This will return to me a list of build hosts that are registered in MLM. And at the next step, step 3, I'm just picking up one of these hosts by random. Of course, this is the most simplistic way to do this. Also, worth mentioning, there's no error handling code in any of these code snippets to keep it simple. But yeah, you can have different strategies choosing a different build host. Like you would probably do it in a round-robin fashion, or even better, you can just check how busy those systems are with some additional API calls, of course, to MLM, and then pick the most suitable one, but programmatically. And then after that, at the fourth step, we schedule the build. That's the actual call to schedule it. So the call to image.scheduleImageBuild with the arguments of my image profile label. Image profile here is the entity in MLM that we keep to know how to build an image. Most critical piece of information that a profile holds is the path to the local Docker file. Online URL or anywhere actually, and also the image store where I'm going to store the built image. So I provide that profile label, and the next argument is the tag of the image, which is none here, that will translate it to latest. And finally, the ID of the build host I've chosen. And with that, it returns me an event ID that I can use to go to the web UI and check the result of the event or the status of the event. So, and then I print the information with the event ID, and then I log out as usual. So that's one of the first things I wanted to show you as an idea how to utilize the API. Going on to the next example, registering and provisioning multiple bare metal systems programmatically. So this time I'm taking the input from a text file. And in that text file, let's imagine we have a handful of FQDNs that are freshly instantiated bare metal machines. So we're going to just go over them and provision them. So again, first up, login. And then you can see that there is a loop here, starting with step 3. And that's just looping my FQDNs for bare metal machines, because I have to repeat this process for each of them. And the first call I'm making to the API is system.bootstrap. So the bootstrap is the process of MLM to register any kind of system to it, basically. So the arguments are here. This is the most simple flavor. The hostname, the SSH port, and the SSH user and path. Of course, like I said, this is a quick and dirty way. There are other ways to bootstrap systems, like with public keys, etc. And yeah, according to the result, if the result is success, I need to get a little bit of extra information from MLM for the newly registered system, mainly the ID of the system. So I'm going to the system search API, and I'm calling system.search.hostname, which is to search the registered system by their host names. And I retrieve that information in an object and assign to the variable called system. And next, at step 5, finally the step to call the API method to provision this system. And that is system.provision. I pass to it the ID of the system and the name of my auto installation profile, which is /15 SP6 here. And with that, I also get an event ID that tracks this process of provisioning. Of course, this is going to take minutes and minutes. But at any step, you can just query the web UI or the API with this event ID to see how it's going. So this part is going to run for each host name, and then finally we log out again. So at the end, the output of this is hopefully a bunch of lines saying provision scheduled with event ID and a bunch of event IDs. So you can just visit any of those events to find the status for. So, second example. And next one is assigning a maintenance schedule to a group of systems. So, maintenance schedules, maintenance windows is a fun, very recent feature we've added to Multi-Linux Manager, which is you're able to define maintenance windows, your systems, and MLM prevents doing any kind of disruptive operations on any of these systems outside of those windows. And the way I'm doing it is by using an iCal file. And let's say I created an iCal file before and I added the maintenance windows in that file as events. So every event in that iCal file is a maintenance window for the systems assigned to it. And here, the second part, second step, I'm calling the API method maintenance.createCalendar with URL. And it accepts the label of this calendar that I pick. And as a final argument, the online URL to the iCal file. And at the third step, I'm creating the actual schedule with using this calendar by calling maintenance.createSchedule. And here I pick a label for the schedule, and there's a keyword multi, which is not important for this example. And then finally, the label of the calendar itself. So at this point, I have a maintenance schedule that I can assign any system to. And when I assign those systems, I am not allowed to do any kind of disruptive operation, patching, rebooting, whatever, outside of those windows. And now I'm going to assign this schedule to my web service. So system groups are another concept in MLM if you're not familiar with them, but they are basically how you group systems to be able to do some operations in using those groups. So here I picked the group of web service. And I need to get the list of these servers by calling the system group.listSystems endpoint and giving it as argument web service. And then in return, I get a list of systems with their details in the variable called web service. And finally, at fifth step, I'm assigning the maintenance schedule to those systems by calling maintenance.assignScheduled-systems. Well, the arguments are, first one is the label of the schedule. Second one is the list of system IDs. Those systems and web servers are full structured objects with a lot of additional data, so I need to extract the ID from them. So it's finally a list of system IDs. And at the last, as the last argument, the keyword cancel, which means that if those systems have already something scheduled that falls outside of these windows, they're going to be just canceled. The other alternative is fail. That will not cancel the actions, but fail them for some reason, if that suits you better. So, and yeah, finally, again, log out. So after this point, none of those web servers can be patched, rebooted, whatever, outside of the maintenance schedules. And that brings me to my final example, and the longest one. So I split it in 3 parts. Also, these 3 parts are logically separate, so we can have a look separately. Yeah, let me stop for a second again, so you can have a look. So what I want to do here is that I have a CV number, and I want to patch, be able to patch every system I can register to MLM with a single code piece. So what I'm doing first here is the second step. I'm calling audit.list systems by patch status. So this gives me a list of systems in different groups of patching status. So I'm only interested in 2 statuses here. First is affected, and there's a patch applicable. And the second is the system is affected, but there is no patch applicable. So I want to know. So I won't be able to patch those, but I want to know, and because I want to report them. So I get those two groups of systems, and also the CV number, of course, here is the second argument. This time I chose to get it from the system arguments, the first argument. So you can just run the script with the CV number as a argument there. And yeah, so I get the systems in the as a list in the systems variable. And then at the third step, I'm preparing to group these into 2 different groups, applicable ones and inapplicable ones. And at the first step, I'm just doing exactly that. I'm going through the systems and check the status of each one. If the patch is applicable, I put it into the applicable bucket. Otherwise, I put it to the inapplicable bucket. So this is all gathering data for preparing. So step 2, we're going to do the actual stuff. So here we start with gathering the advisories that is actually needed to patch these systems. So these advisories necessary are already in the object that I have from the previous steps, the system list here. So like I said before, those systems objects are big objects that include a lot of additional information. So what I'm doing here simply at the step 5 is I'm gathering the advisories I'm supposed to install to be able to remedy those systems. And at the 6th step is a little bit, it's a technical detail step, because like even though I know the advisories, a single advisory can have different, multiple patches in MLM, depending on, like, if you have the same advisory in 2 different repositories, of course you're going to have 2 different patches there. So I need to collect the actual unique patch IDs to be able to, so that I can tell MLM which exact patches are to install. So that's what I'm doing there, with another call to errata.getDetails, which returns me all the details about any patch. And finally, at step 7, the critical step here, is a call to system.scheduleApplyErrata, which is obvious from the name. And to it, I provide a list of system IDs that I gather in the bucket of applicable systems. And the second of all the patch IDs, which will probably be different for some groups of systems. But it doesn't matter, because at the last argument, I also say it only relevant equals true. So if there's a bunch of IDs on those patches, and not all of them are for every system, so whichever for it is relevant, that's going to execute in there. And also here is a date, which I want the date and time that these actions need to be executed. But of course, looking at one of the previous example, I could do it as part of a maintenance window instead of picking a date and time here. And the third step, final step, is the reporting step, which I will print out the results. Well, this could be anything. Like this could be, of course, standard output, or this could be formed as an email for reporting, or anything basically. So first, what I'm doing is at the step 8, I'm just reporting the number of systems that have been patched Also, of course, the number of total systems. And after that, I print a list of advisories that are actually installed. And at step 10, I'm here preparing a full URL of the scheduled action, so that when clicked, you can just directly go to the event details and see the result of the event, patch installation event for each of the systems. And at step 11, I'm checking if I have any inapplicable systems I can patch, which needs attention. So that's what I'm doing there, and I'm printing a number of systems are not assigned the required patches to apply, followed by the actual system IDs of all the inapplicable systems. So that as a next step, I probably need to take care of them. And that was the final example. So yeah, with those examples, I tried to show you the different ideas to be used in the SUSE Multi-Linux Manager API. And yeah, it has a huge catalog. And like I said, we've been adding, and yeah, making it robust to be able to use it like that. So imagine how this could be useful to an AI agent. So it's very well structured. The signatures are well defined, and the API catalog, API documentation is there. When you can feed it to your AI agent, it's going to be a huge step forward in smart automation. So, for example, imagine this scenario. So here we go. This typical interaction with your on-premise LLM, let's say. So I'm writing, hey LLM, do we have any systems vulnerable to this CV number? And it responds, hey there, looks like there are 4 systems affected by this CVE going on, and 3 of these systems have patches available. And he moves on to, would you like me to schedule a patch to these systems in the next maintenance window? And I answer, yes, please. And it does this and says, done. You can view the event status here with a link to the web UI showing the details of the actual action. So if you take a moment to notice, everything here that the agent needs to interact with, we've already seen in the scripts. So this is very easy to plug in this way. So this is kind of one of my visions to integrate API with the rest of your environment. So this sounds really interesting for me. And yeah, that's actually all I wanted to show to you. Yeah, we are actually a little bit short on time, so I'm going to recap some of the things, some of the main points I wanted to make, and after that we will move on for any of your questions, hopefully. So the key takeaways. API-driven automation is a really good way to enhance efficiency and, of course, consistency. So when you have well-written, version-controlled API scripts that you know they're reliable and they're going to execute in the same way after. And APIs provide structured access to data and services essential for AI integration, which I just talked about. And together with API, role-based access control ensures secure access and control for your all API interactions. It sounds a little more important after you consider the AI interaction example. So AI is powerful, so they need to be really controlled in a fine-grained manner. So who's to say that your AI agent doesn't get bored and start checking out different endpoints to do different operations? And yeah, combining API and role-based access control creates a real robust and secure workflows. And yeah, with Multi-Linux Manager, we have all the tools for your any kind of secure automation needs. API providing the tools and RBAC providing the necessary security to work with those tools. And this brings me to your questions. Yeah, let's start.
I have found in the past that support is very hesitant to support homegrown scripts. What is your take on that?
So, yeah, our support for homegrown scripts. So, MLM has a character that it's very, very easy to shoot yourself on the foot. And it's a little bit of a trade-off. So, I mean, of course, we are hesitant on suggesting those kind of things, but yeah. I also think that we need to provide more and more examples, more guys. So even with these examples, like there are pieces of the puzzle, but this is not the whole piece. So I agree. I mean, we should be providing more examples, public repositories with good use cases, which we have actually in the open source version Uyuni repository. We have a separate repository with all these API scripts that we have. But yeah, I agree with you with that. Okay, any other questions? Okay, I guess that's it. Wow, right on time. So thanks for your attention, and yeah, enjoy the rest of your session.